In this video, we're going to talk about what we call the average rate of change. The average rate of change is also known as slope. And what we want to do is find the slope between 2 points of a curve. And when we find that particular line that we're trying to calculate those 2 points with, we call that a secant line. And don't forget that just slope is just equal to, you have 2 points, and we call it A and F of A here and B and F of B. But I want you to realize that this is just x1, y1, x2, y2. And the slope here is equal to y2 minus y1, the change in the vertical, over x2 minus 1, which is the change in the horizontal. The purpose of this now is we can tell if a function is increasing or decreasing based on the slope between those 2 points on any interval. And what that means is, remember that a function is increasing when, if you have 2 points, let's call those points A and B. Here is A and here is B. And then for each value, for instance, at A you have F of A, and at B you have F of B for their values. We can look at those Y values essentially and tell what's happening to the function. For instance, if F of A is smaller or lower than F of B, we know the function is increasing, because what that means is here is A right now at a lower Y value. Here is F of B at a higher Y value. So the function has to be increasing. A function is said to be decreasing if, same concept, this time F of A is going to be at a higher Y value, which means that F of A is now greater than F of B at this lower Y value. And the other thing it can do is it can be constant, which means that F of A and F of B are the exact same values as you come on this line. So F of A is equal to F of B. So this is a definition mathematically of what increasing, decreasing, and constant is. And we can use this knowledge by evaluating this function at 2 different points on an interval. So for instance, here it says the function 2x squared plus 1. All I have to do is take it and evaluate it at x1 at -2. So I'm going to evaluate this function at f of -2. And remember, that just means plug in -2 for every x. So this is 2 times -2 squared plus 1. When I evaluate this, I get 2 times basically 4, so that's 8 plus 1 is 9. I'm going to do the exact same thing at x2. So f of 5 means plug in every x is 5 now. So that's 2 times 5 plus 1. You notice here 2 times 5 plus 1, that's 10. Plus 1 more is 11. So notice that the first point, which is our f of A, our first point at f of A was at -2 for this function, for the x, and then it ended up at 9, so that'll be somewhere like this. And then we went to 5 on the x, and it ended up at 11, so it'll be something like this. So on that particular graph, we can tell that this function is increasing on that interval. You can also use the numbers which say, in this case, here is f of A, here is f of B. By definition, f of A is less than f of B, so the function is also increasing. Same concept right here. This should be read as x cubed. This should just be plus 2x plus 8. We're going to evaluate it at those 2 points. So we have f of -2. And again, I'm just going to plug in x. For x, I'm plugging in -2. So this is -2 cubed plus 2 times -2 plus 8. -2 cubed is -8. 2 times -2 is -4, so that's -8 plus -4 is -12 plus 8 is a -4 when I evaluate. Then I'm going to do f of +2. And again, it is, this time it's 2 cubed plus 2 times 2 plus 8. That's 8 plus 2 times 2 is 4. That's 6. It's 8 plus 4 is 12 plus another 8 is equal to 20. And notice again, by definition, your f of a, which is this value right here, is -4. That is smaller, that is less than your f of b, which is this value right here, which is 20. So by definition, this function is also increasing on its interval.